acceleration equation. So you've probably already passed the speed quiz. I know you've passed manipulate an equation, and now you're looking at the acceleration quiz. Before I get into this, I want to introduce you to these four variables. VF stands for velocity final, and VO stands for velocity original. And if you want to think of it in more, I guess, common sense kinds of terms, velocity final would be kind of like the last thing that you were doing, and velocity original would be the first thing that you were doing. So, or kind of like a before and after. Yeah, I kind of like that too. So this is velocity final would be your after, and velocity original would be your before. So if we look at this speedometer over here on the right, let's just use the speeds that it shows. So let's say you're sitting at a stoplight and your velocity is 0. And then the light turns green and you hit the gas and you wind up doing something like 36 miles per hour. So in this case, which one would be our VF and our VO? Well, the 0 would be our VO because that's what we were doing first. And the 36 here would be our VF because that's what we were doing last. Now, jumping back to the variables here, T is just time, and A is acceleration. You probably figured that one out. So let's just use this example here to write up a problem. How much were we accelerating during this time in here, during this time while the speedometer was changing? Well, our acceleration is a change in velocity over time. It can be positive and it can be negative. Right now, let's just stick with this positive acceleration because we're speeding up. If we were slowing down, it would be negative. But just writing this sentence, change in velocity over time, just by writing that sentence, we actually have our equation already. Because change in velocity is final velocity minus original velocity. Over time, that's just what it says, divided by time. So that equals our acceleration. So we've come up with our equation for acceleration. Acceleration equals VF minus VO divided by T. Okay? So let's fill in some numbers here. Our velocity final was, let's say, 36 miles per hour. And our velocity original was 0 miles per hour. And our time, let's say that it takes us 6 seconds to get up to 36 miles per hour. Why wouldn't I use hours down here? Because, well, think about it. You're not going to take a number of hours to get up to a certain speed. You're probably going to take a certain number of seconds, so that's a more reasonable unit. So let's see what we get here. 36 miles per hour minus 0 miles per hour. That's 36 miles per hour. And 6 seconds. So 6 seconds. So notice here that on top we've got a divided time unit, and on bottom we've got a divided time unit. So even if we switch this to hours, it wouldn't cancel out. So we've got to have 2 time units in our answer. So that means acceleration has 3 units. Please don't freak out. So doing the problem here, numerically we're going to have 36 divided by 6, so that's going to be 6. And what will our units be? Our units will be, in this case, miles per hour per second. That is our answer. That's our acceleration. 6 miles per hour per second. So yes, it does have 3 units. If I were going to write this answer out, if I were going to write that answer out as a sentence, whoops, that sentence would look like this. Each second I went 6 miles per hour faster. So that sentence right there, each second I went 6 miles per hour faster, that describes this chunk of graph up here where, or the speedometer in between VO and VF. I think it's worth saying it again, maybe with a different example. So like, let's say that somebody falls out of a really tall building. No, that's probably not politically correct. Let's take that back. Okay, let's say somebody drops something from a tall building. The acceleration from that tall building here on Earth is about 10 meters per second per second. What does that mean? That means that as this rock, or whatever it is, falls, each second that it falls, it goes 10 meters per second faster. So if it falls for 1 second, its velocity final would be 10 meters per second. If it falls for 2 seconds, its final velocity would be 20 meters per second, and so on. I'm ignoring air resistance here, but you get the idea. So if it fell for, let's say, 5 seconds, its final velocity would be 50 meters per second. So as a sentence, how would you say that as a sentence? You'd say every second that you fell, or that the rock fell, I'm sorry, every second that the rock fell, it would be going 10 meters per second faster. So that's why acceleration has 3 units. Something that I find kind of interesting with these acceleration problems, we use v for velocity, and that's how you'll almost always see the acceleration equation written. It's got the VF and the VO in it. But couldn't you just as easily do it with speed? I think it's interesting that a lot of the problems that you see about acceleration, they just give you, a meters per second or a miles per hour, and they don't say anything about direction. They just say something sped up or it slowed down. You might get a negative answer, so velocity, it's the best way to say it. But in my opinion, if you want to think about it as just speed, you can do that. That's not a big deal. In the next video, I'm going to talk about why turning is acceleration. So even if you keep your speedometer at a steady speed, if you turn, you are accelerating. And I don't want to get into it in this video, but that's going to be coming at you in the near future. 2 more things before I go. Delta. So maybe you've seen like science-y shows or in movies or on TV or whatever, and you see a chalkboard and you'll see something like this. You'll see delta V. Somebody wrote this triangle. That's a pretty ugly triangle. Somebody wrote a triangle. You'll see delta V. This delta, it's not a big deal. When you see a triangle written in a math equation, in your head say it like this: change in. So delta V is change in velocity. It's just a shorthand way of writing this. So we could write, instead of VF minus VO, we could just write delta V. So if you ever see this thing in an equation, don't freak out. It's just a, it's just a, oh, that's ugly. It's just a shorthand way for us to say final minus original. And then the last thing that I wanted to talk about was if you want to look like a snob or smarty pants, you could say, instead of saying the units were meters per second, you could say meters per second squared, because we've got our one distance and two time units here. They don't have to be different. You can say meters per second squared instead of meters per second. So often when I'm talking to classes, I'll drift back and forth between these two, just so that way the students get comfortable with hearing it either way. And then finally, the very last thing I want to say is that on my acceleration mastery quiz, I'm not going to throw different units at you. All of my velocities on that quiz are going to be meters per second, and all of my times are going to be in seconds. So all of my accelerations are going to be in meters per second. And that is it.